Hello everybody, getting ready to do Geometry 1 Math, Lesson 4.6 Part 1, Part 2, Part 3 available here. 4.6 Medians of a Triangle, and we have a classwork sheet for 34 points. If you email me, you can get your classwork sheets. And we have notebook guides of 12 points for this Part 1 here. This would be Part 1, and you can email me for those too. Okay, today, teachers, this is our bell work for today. Write the answer as a fraction, multiplying these fractions here, students, and then find the value of x here. Give your students 5 minutes. Okay, welcome back for our solutions. 16 over 27 will be the answer to this. And then the measure here, 3x minus 4, you know it's equal to 8, so x equals 4 in the here. So a cardboard triangle will balance on the end of a pencil if the pencil is placed at a particular point on the triangle. Finding balancing points of the triangle, finding balancing points of objects is important in engineering, construction, science. So a median of a triangle is a segment from a vertex to the midpoint of the opposite side. So this would be a median here. You go from a vertex to the opposite side. These side lengths are equal. Here's a median here from this vertex down here. And then you have a median up here. And then these sides over here are equal too. Students, in your own words, define median of a triangle and centroid. We haven't defined centroid yet. In triangle STR, draw a median from S to its opposite side. So from S here, side opposite angle S is TR, this side here. So what do we do with that? Find the midpoint of TR and label it. So here would be our median here of TR will be P. Find the midpoint of TR and label it P, then draw a segment from point S to point P. Line SP is a median of triangle STR. This is a median here, 3 and 3 for that. Okay, our guided practice, copy a triangle and draw a median. And then this one here, same thing for you students. Draw a median here. Teachers, give your students about 3 minutes to do this. Copy the triangle and draw a median. Okay, welcome back for your solutions, students. Here would be a median right here, from here over to this side here. That would be a median. You could also go up here, and you can go like this too. And then down here, this would be 1. You got a 2.5, you just go up like this. That'd be a 2.5. And theorem 4.9, intersection of medians of a triangle. The medians of a triangle intersect at centroid. This will be your centroid. There's your definition, students. Go back and fill in your notebook definition. The centroid is a point that is 2/3 of the distance from each vertex on the midpoint of the opposite side. So the medians of a triangle intersect at the centroid, a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. Wow, there's a lot of definition there. If P is the centroid of ABC, then AP, and here's a good way it puts it out. AP is 2/3 AD, so AP is 2/3 of AD. So it'd be 2/3 of the length of this side here. Isn't that cool? So there's all kinds of relationship here when you're finding a centroid of a triangle. Okay, example 2, use the centroid now. We have this situation here. Here's your centroid. E is the centroid of triangle ABC. DA equals 27. DA equals 27. Find EA and DE. So you need to find this, and we need to find DE. We need to find this. So how do we do that? Well, using theorem 4.9, you know that EA is 2/3 DA. So 2/3 of 27 would be 18. So EA would be 18. Now use the segment addition postulate to find ED. So we're going to find that now. DA equals DE plus EA. segment addition postulate. So here we go, 27 equals DE plus 18. And then we use some algebra here. DE equals 9. So that would be the length of DE would be 9. The length of EA's has a length of 18 and DE has a length of 9. Then we have our next guided practice. Use the centroid of a triangle. Here's the centroid here. Students, this is yours down here. Teachers, give your students about 5 minutes to do this. Given JK, find JG and KJ, find BE and ED. Okay, so for our solutions here, ED would equal 8, ED would equal 8. We know BE would equal 2/3, or rather BE would equal 2/3 of BD, so BE would be 2/3 of BD. 2/3 of BD is 24. So it would equal 16, and BE plus ED equals ED. 16 plus ED equals 24. ED would equal 8. And this one up here, using this theorem here. And then again, we do the same thing here. KG equals 2/3 of GJ. So KG would be here, would equal 2/3 of JG. JG, find JG, well, we don't know what JG is. KJ, or rather KG was JK equals JG. We know 2/3 of GJ plus 4. GK is 4, so we plug it into this formula here. We get to -1/3 equals JG equals -4, and then we solve for JG, and JG equals 12. We plug that back in up here, and then KG equals 2/3 of 12, which equals 8. That would be up here. KG equals 2/3 of 12 would equal 8. Yeah, we got to do some maneuvering there, so you have to pay a little bit of attention here to your theorems. Be careful with your calculations. And that was 4.6. Part 1, Part 2, Part 3 is available here. Thank you very much.